Hello and welcome. Thank you for joining our webinar. We will be discussing DevSecOps with Red Hat OpenShift. If you aren't already following us on LinkedIn or Twitter, go ahead and follow us. You can stay up to date on information that we're constantly publishing, webinars like this, or we're having a number of guides and other discussion topics. We also have some other webinars that would be great to listen to, as they are very much related to what we're going to be talking about here today. Now, a little bit about me. I'm a director and co-founder here at Excelno. My name is Josh Minthorn, and my background is in IT consulting. And I started really on the development side. And over my time working with customers, one of the things that I constantly found was that there was always challenges on the development side when we started to do releases when it came to security. Now, throughout my career, while again I focused on the development side, I also was introduced to the infrastructure side of things and eventually to the cloud and everything. And over that time, I started to see also how important automation was. And I can remember times where we would be given infrastructure to deploy applications on, but yet when we went to go do a scan before we did releases to production, there were vulnerabilities and things found on the infrastructure, even though it was vulnerabilities found on the OS, and that had nothing to do with what we were working on, but yet it still slowed us down. And so we're going to be talking about that here today. Now, one of the things here that we do at Excelno is we take our expertise and we help companies adopt DevSecOps, or DevOps with security. And a lot of times, customers may be starting with DevSecOps. They maybe already have started with DevOps. Either way is fine. It's always about how can we get better? And how can we bring security into the fold? And the big thing is that we understand the challenges and the changes required. And more importantly, one of the things that we do, like we're doing here today, is we really like to share our knowledge, mentor, and collaborate and upskill the organizations we work with. That's really what sets us apart. We've worked with a lot of companies. We've seen the mistakes that are made. We want to help companies avoid those same mistakes and really begin to get the benefits of implementing DevOps with security, or DevSecOps. So what will we be going through here today? One, we're going to talk about what is and the importance of DevSecOps, how Kubernetes is secure-ish. Then we're going to be getting into Red Hat OpenShift and DevSecOps. So, what is and what is the importance of DevSecOps? I like this saying because it comes from the FTC. As we all know, government security is very, very important. They did a very lengthy study across a lot of different companies and other organizations within the government, and what they found was, so you can see here, companies that consider security from the start, assess their options, and make reasonable choices based on the nature of their business and the sensitivity of the information involved. Threats to data may transform over time, but the fundamentals of sound security remain constant. So what does all of that mean? One is, it is not one size fits all. There's going to be a different sort of roadmap. There's different levels of security that each organization is going to need. Some organizations have to have very specific compliance because of regulations and other things. Others don't. And it also depends on what are maybe some of the applications, things like that. What it is that an organization really has to choose and understand. But best practices and sound methodologies should be used. In other words, it's not about the tooling. Tooling is important, but it's not about the tooling. Is that when you have those fundamentals in place, then you can very easily adapt and make changes. And that's what's critically important here. So the benefits of DevSecOps, when we think about our current state and our future state. One, we want to increase the speed and rate of delivery. We want to reduce the expense associated with that. That's time, that's people, that's rework, whatever that is, we want to reduce that. We want to reduce effort, we want to reduce the time. That's a goal. We want to have security, we want to have monitoring, and we want to have deployment checks from beginning to end. Not at the end, not almost at the end. We want to do it throughout the process, from beginning to end. We want to make sure that all of IT supports open and transparent communication from development to operations, including security. We want to have security by design, and we need to have the ability to measure. So it's one thing to just have security and have scans, things like that, but we need to be able to measure and know at any point in time what is the current state of things, so that if something is found and it's being addressed, you can measure the progress of whatever that issue is that's been identified as being addressed. We also, and this is related, we want to increase the recovery speed and decreasing troubleshooting time. Something is found, quickly identify it, therefore, if it's quickly identified, you can get to potentially a fix faster. But we've identified it faster. Now, once there is a fix, it can go through testing and be released faster. So you may not be able to necessarily fix something faster. However, the activities that surround that, the identification, the testing, and the rollout and everything can be done faster, therefore reducing time. That also mitigates risk, because the longer a risk is out there, the greater the chance something could happen. We also want to improve security through automation. For instance, CI/CD, immutable infrastructure, things like that. Now, what do we want to do? We want to bring these teams, development, operations, and security. We want to bring them all together. Now, usually we think of security as really having a focus on application security and infrastructure security. But what we do when we bring all these teams together is now development, security, and operations really has a shared responsibility, a shared vision, shared input, shared ownership of application security and infrastructure security. Right? So DevSecOps, what does that really have? Is a comprehensive approach to focusing on security during the building and running of software. So we want to therefore then create a culture where security is that shared responsibility through the entire IT lifecycle. And in working with customers, what we find is that the DevSecOps or DevOps with security mindset is so critically important, because it really puts an emphasis and really values the need to build a secure foundation, building security principles into DevOps initiatives. So it's not just let's automate things, it's also the security piece to all of this. So what are we really trying to do if we just boil this down and think about it purely from a process perspective? A lot of times in the development cycle, we've got the development team and the QA team. They're testing, they're doing demos, they're planning, they're developing. They do that iteratively over and over. And then what happens when they want to go for a release? Well, they bring it over to the security team, who also has maybe a QA team, right? They're maybe focusing on something different than your software quality team. This is about software quality through the lens of security. They're going to be testing, they're going to be reporting, they're going to plan how they're going to test, and they're going to be scanning. And then it's going to go and deploy. Now, if you look at this, everybody's working to get these things accomplished. The thing is, if you look, it goes from one team to the security team, and then it gets deployed. And what really tends to happen there? What tends to actually happen is we see a bottleneck. Right? Development, testing, operations, then it goes to security and it goes back to operations. We can only move, applications can only move as fast, they can only be deployed as fast as security can get through things. And in our experience, we tend to see that there are more and larger operations and development and testing teams than there are security. And so these teams, what are they doing? They're either planning on a release cycle, which makes it, can make it difficult, but also it creates that bottleneck. It is not intentional. By no means is it intentional, but it happens. So what we want to do is we want to get security shifted left. It is on the same playing field, the same plane with development, testing, operations, security, and we've removed that bottleneck. Now, over the years, what we've seen, last couple of years especially, is that the cost of breaches are going up. And this just gives some insight into what some of those costs are. What we've seen over the last couple of years is that the increase in breaches, that average price has gone up 10% with more remote work. And yes, it was always remote, now it's going to go hybrid. The new way of working is there is going to be more remote work. And what we saw was that a remote worker was a factor in a breach cost difference of roughly $1 million per breach, per issue. And when we see that, well, the increase of the cost of that breach in terms of lost business was up 38%. If there's personally identifiable information, roughly the cost is $180 per record. We look at compromised credentials, 20% is the share of breaches initially caused by compromised credentials. 1/5 of breaches are caused by compromised credentials. On average, the number of days to identify and contain a data breach, 287. To put that into perspective, if it was found on January 1st, that means that it would run until, I do the math quickly, almost September, October-ish timeframe to actually identify this breach. That's a long time for that breach to be there. So that breach has been there and then it's identified what else has been happening. So what do we want to do when we're thinking about DevSecOps? One, we want to focus on security at the beginning. We talked about earlier, we removed that bottleneck. Focus on it at the beginning, not towards the end or at the end. We want to increase quality and security with speed. We want to actually get through and determine quality and security faster. And that's going to allow us to what we call reducing cycle time, which is releasing applications. We're going to use automation to reduce vulnerabilities and increase coverage. So scanning and other things there. And then we're going to encourage to build security into everything. Now, when we're talking here today about Red Hat and OpenShift, Red Hat, if you aren't already familiar, we'll talk about this more, but OpenShift is a Kubernetes-based platform to run everything in. It does not do everything that you would typically have for DevSecOps, which for good reason. There's certain fundamental things that OpenShift provides, and what that allows is for organizations, teams to choose how to handle other items. And when we think about that, we'll get into that, which gives flexibility. Again, it's not one size fits all. So what this shows here is that we want to start to scale and automate DevSecOps. We want to scale security. Okay, so this isn't just about one team or a piece of security. However, a piece of security is good, it's incremental. But what this shows, look, some examples of some platforms, and there's a lot more than can fit on this slide, but it does show the cost of a defect from the development side, from that application side, as it goes through every environment. As it starts in dev and goes through each environment, and everyone's going to have slightly different environments, but as you see here, the cost goes up. So if you look at the coding stage versus the production stage, $720 versus $3,930. That's a hefty increase. Hefty increase. If we think about that, 720 versus 3,930. Now what we want to do is we want to focus on starting to standardize processes. Okay, now we've got some other webinars where we talk about this, talk about those here towards the end. But what we typically see is there's two types of pipelines. There's the application side and there's the infrastructure side. Today we're really talking about the application side of things with OpenShift and everything. Red Hat does have Ansible for really more of that infrastructure side of things, just not something we're covering here today. So when we're working with customers and you've got these, right, we say, all right, you've got these two different pipelines. By the way, these are simplified versions of these pipelines. we've got this kind of dev and this ops side of things, and we need to bring security into this, and you can see that. So you've got the dev stages, you've got the ops stages, and now we've got these security pieces to it. And so what I'm really trying to illustrate here is that throughout the pipelines, there's different areas of focus throughout the release process. And one of the things that working with customers that we really make sure that they focus on is, one, let's look at where everyone's at, all these different teams, let's bring everybody together, where and what is being done through all these different DevOps stages, and what about these different areas within these stages on the dev and the ops side from a security standpoint. And we start to outline then what is the pipeline. And so what this is getting to is automation, okay, and having a standardized way to do things. But as you can see, where is security? It's throughout the entire process. It's not at the end. It's throughout the entire process on the dev side and the operations side of things. So then what we work to do is we work with customers to say, for all of these areas, all these things are going to happen, who's the responsible party? Who's going to actually run, let's say, this scan or this testing? And when something is found, how will they communicate? Who will they communicate to? Within what time frame? Things like that. And this is about adopting DevOps with security, or DevSecOps. And then we get to what tools should be selected. Now, there are some tools out in the market that will do a number of these things. There are some tools that only do specific things. The thing here is that if you notice, we didn't start with tools, because DevOps with security, DevSecOps is not about tools. It's about these practices and these methodologies and everything. What I want to show here too is that what we're looking at here is that there's a lot of pieces that come together. So we want to make this comprehensive. We also want to not over-engineer, not over-complicate how we do things. And that's really the goal with Red Hat OpenShift. And we'll get into that here in a moment. Now, what's one of the things with Kubernetes? We have customers that ask questions, other organizations that say, well, what's the difference between OpenShift, Kubernetes, this flavor and that flavor? And we'll get into that. But one thing is, when you think of OpenShift, the way Red Hat came about it is it needs to be secure. It absolutely has to start with security. And why? Let's take a little bit of a step back and think about Kubernetes and security. Well, Kubernetes going cloud native, what's the concern? Google the other year recognized that users struggle to configure Kubernetes correctly. This isn't just running applications, getting an application into Kubernetes. This is actually deploying and managing and configuring Kubernetes, that operational piece, that administrative piece, where when not done properly or incorrectly, because it is complex, can create security breaches. And the thing is that, two things everyone knows about Kubernetes are, first, that it is one, the critically important container orchestration space. It is the de facto. It is quite literally the Kleenex or Xerox. Right? Kubernetes is container orchestration. It's just synonymous with it. That's just what is done. There's different flavors out there, but it's Kubernetes. And it is one that space accurately and for good reason. And the other part is that its complexity is both a barrier to adoption, we see it all the time, and is a common cause of errors. So complexity is a barrier to adoption, and that barrier could be lack of adoption, it could be slowness in adoption, but it's also a common cause of errors, which is also going back to the first part, users struggle to configure Kubernetes correctly. The same article, it mentions that it roughly takes organizations about 9 months to really get kind of Kubernetes up and running, just vanilla Kubernetes, because they have to learn it. There's a lot of things to it. It's really to really get it into that state where it's really ready. I'm not going to say prime time, but it's better than after a week or two or a month. 9 months, that's a long period of time. Now, the thing is that, Kubernetes is great. However, let's think about security. That's what we're talking about here today. So we see these things where unfixable security Kubernetes hole, man-in-the-middle attacks, security bug allows attackers to brick clusters, things like that. So what does this mean? Again, going back to security, you might be thinking, well, won't these things impact OpenShift as well? Yeah, absolutely, they could. Difference is that Red Hat is focusing on security. It's done things, and as an organization, Red Hat would work to troubleshoot and find these and support customers. Because if you rolled Kubernetes on your own, you have to do this. You have to wait for this. Whereas Red Hat's going to work to find a fix, to implement a fix. They are the second largest behind Google contributor to Kubernetes. And if you look here, primary challenges, adopting this is from, what is the biggest concern with going cloud native? What's that first thing? Security and cloud compliance, and then complexity. So right there, two things that we saw with Kubernetes. So two of the top three things are this, and then you see cost. Well, if something, there's a security issue to it, and it's complex and takes a long time and a lot of overhead, if you will, people, time, well, that feeds into cost. So all of these things are very much related. So let's think about Red Hat OpenShift and DevSecOps. So it is enterprise-grade Kubernetes. It is based on Kubernetes. It's the foundational container orchestration platform underneath. However, what Red Hat has done is it has simplified it from the installation to the administration and the operation. You can there's a couple of ways to get an OpenShift cluster or clusters up and running, and they can be up and running in a matter of 30 to 45 minutes, fully secure. Now, when I say that, we've heard customers say, well, I can go do the same thing in one of the public cloud providers. You can have a cluster up and running. But what about all the security? What about the logging? What about the role-based access and all of the other controls? All of those things you then have to go and do in addition to getting a Kubernetes cluster up and running. With OpenShift, everything is done. So it is now a very simplified experience, both administrative but also for developers, and security is a core component. Now, there's another piece that's also focuses on in this piece around security, and we're going to dive into that a little bit more. Now, Red Hat calls it OpenShift Platform Plus, and it takes management and security into the fray of things of this, if you will, and it gets into what is known as advanced cluster management for Kubernetes, advanced cluster security for Kubernetes, and Red Hat Quay. Now, I will say for advanced cluster management for security, Kubernetes, and advanced cluster management, and Quay actually, you do not have to have OpenShift to actually use those. You can use them on any version of Kubernetes. It also works with OpenShift. And we're going to dig down a little bit further here shortly around what those things provide. But again, it's about, even if you're not using OpenShift, it is very security focused, and you're using other platforms, Red Hat has said, look, you may not be using OpenShift, but we want to make sure that you are securely managing your clusters and being able to securely and understand what's running in those environments, in those clusters, but before it gets in there and while something is running. That's where Quay and ACM, Advanced Cluster Management, and ACS, Advanced Cluster Security, comes into play. Now, OpenShift is secure at every layer. So one of the things that it does is that there's what is known as Red Hat Core OS. It's a slimmed down version of Red Hat Linux, and it is specifically meant to be lightweight, and it is specifically meant for OpenShift. It is, if you think about it, it's an integrated OS in which OpenShift runs on. And the reason that's there is it's about security and being comprehensive, because Red Hat supports the underlying OS in which then OpenShift, the platform, runs on. And that is, again, that is all about security. And so it helps minimize the attack surface. Therefore, it's also controlled immutability, because you actually don't go and make any changes with CoreOS. What Red Hat does is, as part of OpenShift running and the install, everything gets configured for you. And so when there is an update, let's say there's a security update for OpenShift, CoreOS and OpenShift gets updated all in one. You're familiar with SE Linux, that is on by default. It is also moving over to referred to as Cryo Container Runtime. This is all going more towards standard-based as opposed to, the Docker runtime and other things. Audit D for host-level auditing. You can actually turn on a configuration to make it FIPS enabled, and that's for the government. So again, thinking about it from the security perspective. Now, the other piece too is that when we are running containers, what Red Hat provides is what is known as the Red Hat Universal Base Image. And actually that is free to anybody. You don't have to be a paying Red Hat customer to get the Red Hat Universal Base Image. What that does, Universal Base Image allows you to build containers using Red Hat Linux, as opposed to other distros that are used widely. They are not enterprise grade. So anybody can use this. They are supported by Red Hat. They release updates to them, and you can build containers off of this. And we highly recommend with our customers, whether they're in OpenShift or not, that they always are using images and building images off of the Red Hat Universal Base Image. Because if Red Hat finds anything, they will provide a fix and they'll provide an updated version, or you don't get that with other distros. The other part in here is the security context constraints. Again, that is, there's resources running, and what are they allowed to do? There's different layers, there's different levels set by default. You can override them, but it's kind of, hey, think about this. And I always bring this piece up too. Other Kubernetes distributions will allow containers to run as root. Even though it's done, it is considered a bad practice. It's a security issue, and it's considered a bad practice in general. Red Hat OpenShift out of the box does not allow containers to run as root. You actually have to turn off a setting to do that, and you have to confirm that 2 or 3 times, because you really should not be doing it. And we have heard customers say, oh, developers, they were trying to run these images for, let's say, Docker Hub or elsewhere, but they're not working in OpenShift. And what we've always found is that those container images are not safe because they're running with a root user. So it's not that they're not running in OpenShift per se, that it's an issue with OpenShift. OpenShift is saying, these are not secure. You really shouldn't be running these. And it's really kind of warning to say, you shouldn't be running this. So again, security is at the forefront. That's what this is all about. You get into things like networking security, which both networking teams and security groups that we're always working with, they love this because you can get into micro-segmentation, and it's software defined, so it's very easy to do. And now you start to get in and be able to do things around like GitOps and configuration as code, which allows things to be easily defined and changed very easily, and all those changes get tracked because they're configuration files. So it's even fine-grained networking security that you now start to get. So you've got your images, you've got the platform with an OS, you've got your images, you've got now networking. And then what you can do is you have these compartmentalized projects. So what that means is that you can have a shared environment. You can have multiple teams working in OpenShift, and based on how users log in, because you have OAuth with role-based access, that means that when I log in, let's say I'm a developer on a team, I can only see the projects I'm allowed to see. I cannot see others. It also means that I can't see what else is running. And so yes, it's a shared environment, but things are compartmentalized. So security at a lot of different layers. Again, does Kubernetes provide some of this? Absolutely. But a lot of these things if you did not use OpenShift and you use, let's say, something else, they're only going to provide the Kubernetes layer. They don't provide all the other things that go around it. This just goes in to show how these layers build up. So again, when we think about this, think of these DevOps toolings, these DevSecOps toolings. We talked about networking. We talked about security. You can run OpenShift anywhere. So now you have a consistent experience, not only for developers and administrators and things, whether it's on-prem or in a cloud, or what we're seeing quite often is multi-cloud, or some version of all of those together into a hybrid mix. Again, we always talk about the developer experience, the operating experience, but now you have security at scale as well, because you can secure all of these clusters in the same way. And that's important as well. And so you see how these layers build up with wherever it needs to run. You've got CoreOS, you've got Kubernetes, and these other services and the other things that Red Hat puts on it. The other part too is it's built-in monitoring and logging. So you have that built in. You can also pipe that into other third-party platforms, Splunk, Datadog, you name it, so that you can already leverage something that you have. But if something does happen, you can get it out so that you can alert the right folks when something needs to be looked at. Now, we talked a little bit about OpenShift and ACM and ACS and Quay. Wanted to simplify what this looks like. So you have multiple Red Hat OpenShift clusters. You want to be able to manage those. You want to be able to spin a cluster up or tear a cluster down, and you want to do that in a very standardized way so that, we call them policies, configuration policies and other things are applied. What that does is that removes the human element of forgetting to configure something or what have you. So it's not only tearing up and tearing clusters down with advanced cluster management, but if you need to make a change in configuration, you can state what the new policy is and have that pushed out to all of the clusters. So let's say that there's been a change from security guidance, from security teams. So you have to make a change. You change it in advanced cluster management, and now you can push that out, coordinate with the teams, and you now have tracking, if you will. Say, all right, across all these clusters, we've done, let's say, cluster 1, cluster 2, cluster 3, we're scheduled to do this on so-and-so date. So again, being able to control that. The other part too is being able to have fine-grained control of applications and where they go. You might say, well, wait a minute, why wouldn't you do this in a CI/CD process? Do. Absolutely do. You want to do it in both. Why? To safeguard. It might be that some mistake is made, something happens in the CI/CD process that you still don't want something to be deployed to the wrong cluster. So again, it might happen. This is a safeguard to say, even though this is being done, this can't be done. Cluster security, two pieces to this. We've got containers. We want to make sure containers don't run as root, certain things aren't done, all sorts of things. There's default policies, but you can define your own. And what this is that advanced cluster security will scan before a container is built to see if it meets policies. If everything is good, the container gets built, that's part of that CI/CD process. But then what happens when the container is actually running? It's constantly, you can scan that too. Why? Because it might be that a vulnerability is found in running containers. Vulnerabilities come up all the time. You want to know about that. So you can go and see all of them that are impacted. Policy might change on containers. You want to know which ones are impacted. So it's not just about, oh, we scanned it when we built it, so everything is good. You want to do that in advance, or excuse me, you want to do that in advance, and you also want to do that while it is running and operating. Both sides of that, as opposed to just, well, it was only scanned before we built it and everything was good, right? We want to also do it while operating. And then there's Red Hat Quay, which is an enterprise-grade trusted image store registry. That also has built-in scanning. There are a lot of container registry products out there. However, only a few of them really do scanning. We're starting to see that change, but this is an enterprise grade that you can host and run. Now, obviously, with all this being from Red Hat, it all integrates very easily together with OpenShift. So you now have a comprehensive, cohesive ecosystem, all supported by the same company, built to integrate together. That being said, if you don't have OpenShift, you can still use advanced cluster management. You can still use advanced cluster security. You can still use Red Hat Quake. So as we start to wrap up here, I just wanted to show a little bit more of, here's some things around advanced cluster security. As you can see, here's vulnerabilities that have been found in some clusters. And you can see some of the CVEs and what's the score, what's the impact, and from a percentage in terms of the environments. And then what's, based on that, what's the overall score? So a number of things that can be done here. So this gives insight to, let's say, a security or an operations team around what's running in these clusters. Again, this just shows from a dashboard perspective, violations by cluster, how many violations you have overall, and things here. So it's really and truly, again, what is running in the clusters and getting insight into that, to tracking in the metrics. What this shows is a network graph of things talking to each other. This is always good because, let's say something is found, you want to know that not just kind of blinders on this one thing was impacted, but what is the potential impact to other things that needs to be done. The other part with this too is this networking. You can start to see, and this goes going back to networking with microsegmentation, is that it might be found that some of these things are talking to each other and they should not be. So maybe something was not configured correctly. Now, I will say that goes into advanced cluster management around those policies and the standardized configurations. But if you don't have that, that's okay. Again, this is just another way to see how things are connected, especially as more and more applications get deployed into Kubernetes and they get smaller. Going from monoliths to microservices, you've got more and more things running. I like to think of it as you're going from massive cargo ships to a bunch of little jet skis all over the place and running. We got to keep track of everything because everything is still doing something. Here's advanced cluster management to give you an idea. As you can see here, one for Google, one for Amazon. You can have one in Azure. You can have on-premise. It's about managing all of the clusters and really having a single dashboard to manage that. Manage the configuration, bring up a new cluster, tear down a cluster. It's that comprehensive management piece. And you can see pieces about that and everything. This talks about here, so this is the governance and risk. So being able to define policies around what gets deployed. And when something is deployed, how do you make sure that it's deployed correctly each time and that there's configuration that gets applied? Maybe it needs to integrate and feed out to, let's say, an external platform, a Datadog, PagerDuty, whatever it is. You want to make sure every cluster does that. And there's certain things about every cluster, right? Maybe there's an identifier that feeds based on the environment or whatever it may be. Maybe the region, maybe both. Maybe where it is. Maybe it's dev in Google, or there's a dev in Amazon. You want to have that information. This allows you to make sure that those policies, when you deploy something, has that information, and it's done in a very standardized way. So that's what we have here today, as you can see, with Red Hat OpenShift. Very comprehensive platform in and of itself that starts with security, but then where does it go? Right? We have advanced cluster management to be able to manage one or multiple clusters, standardized configuration, control where apps can and cannot run, advanced cluster security, about building containers and scanning and how everything is there, applying policies, and then also once they're running. And then you need to store these images somewhere, and that's where Quay comes into play, and the scanning that is part of that is included with Quay. And then there's OpenShift as a core, as a platform, right? With Core OS, not allowing containers to run as root. When you're building containers, right? Using the universal base image. right? When containers are running, right? Microsegmentation, software-defined networking, allowing users when they log in, OAuth, and actually applications too, right? You want to encrypt everything. So a very comprehensive platform. In automation, so there's within OpenShift, when we think of DevSecOps, CI/CD, there's Tekton, which is a CI/CD pipelining framework specifically meant for Kubernetes to allow you to do things such as GitOps. That's where Argo CD comes into play. Now, if you don't have some of these things or you already have something else, that's okay. You may have already have something else. Use what you already have, enhance it, and integrate it with OpenShift. Because again, the goal is to provide a secure platform to securely manage all of the applications. And two, one, decrease the potential breach, decrease the time it takes to identify a breach, to address a breach, and everything else we saw as these costs continue to rise. We also, right, thinking about this, reduce the complexity of rolling out OpenShift. As I mentioned, you can have a cluster with everything that we've talked about here up and running in less than an hour, and reducing the complexity. And that's the key piece here. So if you are starting your DevSecOps or DevOps with security journey, and you're looking for someone to help either build a strategy or help you implement your strategy, we can help. We're experts at this. We've done this time and time again. You can reach out to us at hello@excelino.io. You can go through our website and through our social platforms like LinkedIn and Twitter. So I do want to say thank you for joining our DevSecOps with OpenShift webinar. We also just wrapped up not long ago a 3-part DevSecOps series where we cover the what is DevSecOps, why DevSecOps, and how to get started with DevSecOps. It covers some of the things we talked about here today in greater detail. Not with the OpenShift piece, but really more around some of the fundamentals and things. Because again, DevSecOps is not about tooling. Tools are tools. It's about really those fundamentals and making sure you're crafting your own journey, your own adoption, and then measuring that. By the way, if you aren't already following us on LinkedIn or Twitter, go ahead and give us a follow so you can stay up to date on the information that we are publishing. For instance, webinars like this, ones we've done before, podcasts, and other discussion topics. I hope you enjoyed today and you found this informative. We look forward to seeing you again in any of our future webinars and podcasts. And as always, don't ever hesitate to reach out to us. We are here as experts to help, consult, and guide, and help you with whatever you're trying to do. Thank you.